Hello, good morning friends. Today I want to explain you Cauchy's residue theorem. This is one of the important theorem in the complex analysis. Suppose we know the Cauchy's integral theorem and Cauchy's integral formula, so it is easy to understand this Cauchy's residue theorem. This is an extension of Cauchy's integral formula. The statement is if C is a simple closed contour or it is a curve in the domain D and f of z is a analytic function in D except at finite many points z1, z2, z3 dash 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 zn in the interior of C, then contour integral of f of z dz is equals to 2 pi I of a sum of residues r1 plus r2 plus r3 dash 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 rn. R we can represent it as f of z contour integral of f of z is equals to 2 pi I sum of residues at each pole within the contour C. Let us move to the proof of this theorem. So, see this picture is showing the domain D. Within domain D there are some circles having the different radiuses and different curves inside D, and that all the small circles which are included in the contour C. You are seeing this contour C here, and it is covered by the domain D, and it has been drawn along x and y axis. Now, there is a C1 having the Z1 as the radius, C2 having the Z2 as the radius, C3 is having the Z3 as a radius. Similarly, we consider up to Cn and Zn. Cn is the contour, nth contour, and its radius is Zn. Let us describe this picture. Let C1, C2, C3 dash 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 Cn be circles with centers Z1, Z2 dash 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 Zn respectively. That is, C1 is a circle having the Z1 as radius, C2 is a circle and having the Z2 as the radius, and Cn is a circle, nth circle having the Zn as the radius of that circle, which are inside are enclosed by curve or contour C and the domain D Now, these all lie inside the contour C and they don't overlap on each other. F of z is given that it is analytic within this domain D. F of z, in the statement only it is given that it is analytic in the domain D. Now, by using the Cauchy's integral theorem for multi-connected region, we have contour integration of f of z dz is equals to contour integration at C1 f of z dz plus contour integration f of z dz for the contour C2 dash 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 contour integration f of z dz Cn. We know that the residues of each residue of function at each contour is given by, suppose I am considering the C1 as the contour and Z1 is the radius of that contour. Now, suppose I want to calculate the residue, I will apply the definition using the definition of residue. So, I can find the first residue for the first circle which is inside C1 is that R1. R1 is the residue at circle C1. Is given by 1 by 2 pi I integral over C1 f of z dz. So, now I will cross multiply that 2 pi I will goes to R1. So, that will become 2 pi I into R1, and which is equals to the integral contour integral over C1 f of z dz. So, for the first circle the result is 2 pi I r1. Similarly, we can find the residue for the f of z integral over C2 is 2 pi I r2. R2 is the second residue of the circle C2, which is having the radius as z2. Similarly, we can find nth up to C3, C4, like that we have to come up to nth circle or nth contour of the integral calculation over Cn f of z is given by 2 pi I for the contour Cn. Substituting these all values in equation 1. The equation 1 is what? This first one is the equation 1. This is equation 1. So, I have to substitute the value of this, and value of this. So, we get f of z dz is equals to the first, the second, third and fourth one. Similarly, taking 2 pi I is the common factor, then we will get this thing. So, this is nothing but the sum of residues at each poles within Ci's or C1, C2, C3 up to Cn. So, this is what the residue Cauchy's residue theorem's result. So, f of z dz under the considered contour C is nothing but 2 pi I times the sum of the residues at each pole of the contours C1, C2, C3 up to Cn. By using this formula, we can evaluate the integrals under the given contour C, which are enclosed in the domain D. Thank you.